Electrical codes are continually updated for safety reasons. As new technologies emerge and our understanding of electrical systems improves, the codes are revised to reflect best practices and minimize the risk of electrical fires, shocks, and other hazards. NM cable, also known as Romex, is a type of electrical cable commonly used in residential and light commercial applications. However, in certain commercial occupancies, NM cable is prohibited by the National Electrical Code, or NEC. The reason for this prohibition is that NM cable is more susceptible to damage in commercial environments compared to other types of cables, such as metal-clad cable or conduit. In commercial buildings, there is often more foot traffic, heavy equipment, and potential for physical damage to cables. Damaged NM cable can create a fire hazard, especially in older buildings with hidden electrical systems. In the 2020 NEC, the prohibition on NM cable in commercial occupancies was expanded to include all commercial buildings, regardless of size or type of occupancy. Previously, NM cable was allowed in certain commercial spaces, such as small offices or retail stores. This change in the code reflects the increasing recognition of the potential fire hazards associated with NM cable in commercial settings. The code change does not require the removal of NM cable from existing commercial buildings. However, any new electrical work in these buildings must comply with the new code, which means using a different type of cable than NM. While it may be frustrating to have to remove existing NM cable in a commercial renovation, it is important to remember that electrical codes are in place for a reason to protect people and property. By adhering to the code, one is helping to ensure that the building is safe for its occupants and visitors. The NEC is a comprehensive set of standards and guidelines for electrical wiring and equipment installation in the United States. It is developed and updated by the National Fire Protection Association, or NFPA, and is widely adopted by states and municipalities. The NEC is not law itself, but it becomes legally binding when it is adopted by a jurisdiction. The purpose of the NEC is to safeguard persons and property from hazards arising from the use of electricity. It covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. The NEC is updated every 3 years to reflect changes in technology and best practices. The NEC is organized into chapters, articles, and sections. Each chapter covers a broad topic, such as wiring methods or equipment. Articles provide more specific requirements for particular types of installations or equipment. Sections contain detailed rules and regulations. Some key areas covered by the NEC include, firstly, wiring methods, which specifies the types of wiring allowed for different applications and environments, including requirements for conductors, cables, and raceways. Secondly, overcurrent protection, which requires the use of circuit breakers and fuses to protect electrical circuits from overloads and short circuits. Thirdly, grounding, which provides requirements for grounding electrical systems to minimize the risk of electrical shock. Fourthly, equipment installation, which specifies how to install various types of electrical equipment, such as lighting fixtures, receptacles, and appliances. And fifthly, special occupancies, which addresses the unique electrical requirements for certain types of buildings and locations, such as hazardous locations, healthcare facilities, and swimming pools. The NEC is a complex document, and it is important to consult it carefully when designing and installing electrical systems. It is also important to stay up to date with the latest edition of the NEC, as changes are made regularly. It is essential for electricians, contractors, and inspectors to have a thorough understanding of the NEC to ensure that electrical installations are safe and compliant. Failure to comply with the NEC can result in fines, penalties, and even legal action. The NEC also plays a crucial role in preventing electrical fires. Electrical fires are a leading cause of property damage and injury in the United States. By following the NEC requirements for wiring methods, overcurrent protection, and grounding, the risk of electrical fires can be significantly reduced. The NEC also helps to protect people from electrical shock. Electrical shock can occur where a person comes into contact with a live electrical conductor. By following the NEC requirements for grounding and equipment installation, the risk of electrical shock can be minimized. In addition to its safety benefits, the NEC also helps to ensure the reliability of electrical systems. By following the NEC requirements for wiring methods and equipment installation, electrical systems are more likely to operate properly and without interruption. The NEC is a valuable resource for anyone involved in the design, installation, or inspection of electrical systems. It provides a comprehensive set of standards and guidelines that can help to ensure that electrical installations are safe, reliable, and compliant. Understanding the NEC is essential for anyone working with electricity. It is a complex and ever-changing document, but it is also a critical tool for protecting people and property from the hazards of electricity. There are many resources available to help people learn about the NEC, including training courses, workshops, and online resources. It is important to take advantage of these resources to stay up to date with the latest changes to the NEC. The NEC is not just a set of rules and regulations. It is a living document that is constantly evolving to meet the changing needs of the electrical industry. By staying informed about the NEC, one can help to ensure that electrical systems are safe and reliable for everyone. It is also important to remember that the NEC is not a substitute for good engineering judgment. The NEC provides minimum requirements, but it is always important to consider the specific circumstances of each installation and to use good engineering practices. The NEC is a valuable tool, but it is only one part of the overall effort to ensure electrical safety. It is important to work with qualified professionals and to follow all applicable safety procedures when working with electricity. The NEC is a complex and important document that plays a critical role in protecting people and property from the hazards of electricity. By understanding and following the NEC, one can help to ensure that electrical installations are safe, reliable, and compliant. Now, let's delve deeper into the specific changes regarding non-metallic sheath cable, also known as NM cable, in commercial occupancies as outlined by the National Electrical Code, or NEC. These changes are not arbitrary but are rooted in a comprehensive understanding of the risks associated with NM cable in such environments. NM cable, characterized by its plastic jacket encasing insulated conductors, is a popular choice for residential wiring due to its ease of installation and cost-effectiveness. However, its susceptibility to physical damage and limited resistance to fire make it less suitable for commercial settings. Commercial buildings, unlike residential structures, typically experience high levels of activity, including heavy foot traffic, movement of equipment, and potential exposure to harsh environmental conditions. These factors increase the likelihood of NM cable being subjected to physical stress, abrasion, or impact, which can compromise its insulation and create electrical hazards. Furthermore, commercial occupancies often have higher fire risk profiles compared to residential buildings due to the presence of flammable materials, complex electrical systems, and larger occupant loads. In the event of a fire, NM cable can quickly melt and contribute to the spread of flames, posing a significant threat to life and property. The NEC decision to expand the prohibition of NM cable in commercial occupancies reflects a proactive approach to mitigating these risks. By restricting the use of NM cable in these environments, the code aims to enhance the overall safety and resilience of electrical systems, reducing the potential for electrical fires, shocks, and other hazards. 2020 NEC specifically broadened the scope of the NM cable restriction to encompass all commercial buildings, regardless of size or occupancy type. This change eliminated previous exceptions that allowed NM cable in certain commercial spaces, such as small offices or retail stores. The rationale behind this comprehensive approach is to ensure a consistent level of safety across all commercial settings, recognizing that even seemingly low-risk environments can be susceptible to electrical hazards. It is important to note that the NEC changes do not mandate the removal of existing NM cable installations in commercial buildings. However, any new electrical work or modifications to existing systems must comply with the revised code, which requires the use of alternative wiring methods such as metal-clad cable or MC cable or conduit systems. MC cable provides enhanced protection against physical damage due to its metallic sheath, while conduit systems offer superior fire resistance and mechanical strength. Electricians and contractors working on commercial projects must be aware of these code changes and ensure that all new electrical installations adhere to the latest requirements. Failure to comply with the NEC can result in fines, project delays, and potential liability in the event of an electrical incident. Understanding the rationale behind the NM cable restriction is crucial for making informed decisions about electrical wiring in commercial buildings. While the initial cost of alternative wiring methods may be higher, the long-term benefits of enhanced safety and reliability outweigh the short-term expenses. Moreover, adhering to the NEC demonstrates a commitment to responsible electrical practices and helps to protect the lives and property of building occupants. In summary, the NEC changes regarding NM cable and commercial occupancies are driven by a desire to minimize electrical hazards and enhance safety in these environments. By restricting the use of NM cable and promoting the use of more robust wiring methods, the code aims to create safer and more resilient electrical systems in commercial buildings. Electricians, contractors, and building owners must stay informed about these code changes and ensure that all electrical work complies with the latest requirements. This proactive approach is essential for protecting people and property from the risks associated with electricity. Furthermore, the choice of wiring method is not solely dictated by the NEC but also depends on specific project requirements, environmental conditions, and budget constraints. It is essential to consult with qualified electrical engineers and contractors to determine the most appropriate wiring solution for each application. They can assess the risks associated with each wiring method and recommend the best option based on factors such as fire resistance, mechanical strength, corrosion resistance, and electromagnetic interference. In addition to NM cable, other types of wiring methods are available for commercial applications, each with its own advantages and disadvantages. These include, firstly, metal-clad cable or MC cable, which consists of insulated conductors enclosed in a flexible metallic sheath, providing enhanced protection against physical damage and fire. Secondly, electrical metallic tubing or IMT, a thin-walled steel conduit that is easy to bend and install, offering good protection against physical damage and corrosion. Thirdly, rigid metal conduit or RMC, a thick-walled steel conduit that provides the highest level of protection against physical damage and fire, suitable for harsh environments. Fourthly, liquid-tight flexible metal conduit or LFMC, a flexible metal conduit covered with a liquid-tight jacket, used in wet or damp locations. And fifthly, cable tray, a system of open metal trays that support and route cables, commonly used in industrial and commercial buildings for large cable runs. Each of these wiring methods has specific installation requirements and limitations, which must be considered during the design and construction phases. The NEC provides detailed guidelines for the installation of each wiring method, including requirements for supports, terminations, and grounding. It is important to follow these guidelines carefully to ensure that the electrical system is safe and compliant. In addition to the NEC, other codes and standards may also apply to electrical installations in commercial buildings, such as local building codes, fire codes, and accessibility standards. It is essential to consult with local authorities and qualified professionals to determine all applicable requirements. Proper planning and coordination are essential for successful electrical installations in commercial buildings. This includes developing detailed electrical drawings, selecting appropriate equipment and materials, and coordinating with other trades to avoid conflict. It is also important to conduct thorough inspections and testing to ensure that the electrical system is installed correctly and operates safely. Electrical safety is paramount in commercial buildings, and all electrical work should be performed by qualified and licensed electricians. Regular maintenance and inspections are also essential for ensuring the continued safety and reliability of electrical systems. Building owners and managers should establish a comprehensive electrical safety program that includes regular inspections, testing, and maintenance. This program should also include training for employees on electrical safety procedures and emergency response. In conclusion, the NEC changes regarding NM cable in commercial occupancies are part of a broader effort to enhance electrical safety and reliability in these environments. By understanding the rationale behind these changes and following all applicable codes and standards, one can help to protect people and property from the hazards of electricity. Electrical safety is a shared responsibility, and everyone involved in the design, installation, and maintenance of electrical systems should be committed to ensuring a safe and reliable electrical environment.